Question 1. What is a core differentiator of MLOps data pipelines compared to traditional data pipelines primarily focused on business intelligence? Option A. MLOps data pipelines only handle structured data. Option B. MLOps data pipelines are specifically engineered for reproducibility, versioning, scalability, and data quality for model performance. Option C. MLOps data pipelines do not require orchestration or schedule. Option D. MLOps data pipelines are solely focused on real-time data processing. The correct answer is MLOps data pipelines are specifically engineered for reproducibility, versioning, scalability, and data quality for model performance. Here's the explanation. The overview explicitly states, unlike traditional data pipelines primarily focused on business intelligence, MLOps data pipelines are specifically engineered to meet the stringent requirements of machine learning workflows, reproducibility, versioning, scalability, and data quality for model performance. Question 2. In an MLOps data pipeline, which component acts as a centralized repository for curated, versioned, and ML-ready features, making them discoverable and consistently available for both model training and online inference? Option A. Data lake. Option B. Data warehouse. Option C. Feature store. Option D. Message queue. The correct answer is feature store. Here's the explanation. The how it works and key features components sections, as well as exam tips, emphasize the critical role of a feature store as a centralized repository for curated, versioned, and ML-ready features, making them discoverable and consistently available for both model training, batch access, and online inference, low latency access. Question 3. An e-commerce company wants to continuously retrain its recommendation engine with the latest user interaction data without manual intervention. Which MLOps data pipeline characteristic is most crucial for enabling this continuous retraining? Option A. Manual data cleansing performed by data scientists. Option B. Automation of data ingestion, transformation, and feature engineering. Option C. Exclusive use of batch processing for all data. Option D. Storing all raw data in a single, unstructured file. The correct answer is automation of data ingestion, transformation, and feature engineering. Here's the explanation. The overview highlights automation as crucial for enabling continuous integration and continuous delivery (CI/CD) practices for machine learning, allowing models to be retrained and updated frequently with fresh data without human intervention. The automated feature engineering for continuous model retraining use case directly supports this. Question 4. The principle garbage in, garbage out is particularly relevant for ML models. Which MLOps practice directly addresses this by systematically checking dataset characteristics against predefined rules and baselines? Option A. Model monitoring. Option B. Data transformation. Option C. Data validation. Option D. Feature engineering. The correct answer is data validation. Here's the explanation. The overview explicitly states, the principle of garbage in, garbage out holds especially true for machine learning models. Data validation goes beyond simple data cleaning. It involves systematically checking the characteristics of datasets against predefined rules, expectations, and baselines. Question 5. Which type of data validation involves checking if user_age is between 0 and 120, or if gender is one of male, female, or other? Option A. Schema validation. Option B. Statistical validation. Option C. Completeness validation. Option D. Value validation. The correct answer is value validation. Here's the explanation. Value validation is defined as verifies the integrity and correctness of individual data points. This includes range checks, e.g., age must be between 0 and 120. Categorical checks, e.g., gender must be male, female, or other. Uniqueness constraints, and format validation. Question 6. A deployed recommendation model starts receiving user requests with a new, unexpected categorical value for product_category that was not present in its training data. Which component of data validation would most likely detect this issue during real-time inference? Option A. Schema validation. Option B. Value validation, specifically categorical checks. Option C. Completeness validation. Option D. Consistency validation. The correct answer is value validation, specifically categorical checks. Here's the explanation. The how it works section under value checks mentions, do categorical values match the allowed set? The use cases section also clarifies that for a recommendation engine, Data validation checks if incoming request payloads match the expected schema and data types, including whether item_category is a string from a predefined list. This falls under value validation. Question 7. Which of the following is not considered a core dimension of data quality in MLOps? Option A, accuracy. Option B, completeness. Option C, scalability. Option D, timeliness. The correct answer is scalability. Here's the explanation. The key features/components, section lists, accuracy, completeness, consistency, timeliness, validity, uniqueness, integrity as core dimensions of data quality. Scalability refers to the ability of a system or pipeline to handle increasing workloads, not a characteristic of the data's fitness itself. Question 8. What is a significant consequence of poor data quality in an MLOps environment? Option A, enhanced model interpretability and explainability. Option B, reduced need for continuous model monitoring. Option C, model performance degradation, unreliable predictions, and wasted computational resources. Option D, automatic prevention of data drift without further intervention. The correct answer is model performance degradation, unreliable predictions, and wasted computational resources. Here's the explanation. The overview states, poor data quality is a leading cause of model performance degradation, unreliable predictions, and wasted computational resources. The exam tips also reiterates that it leads to model performance degradation, e.g., model drift, biased predictions, lower accuracy, wasted resources, and unreliable ML systems. Question 9. In MLOps, when does data quality typically get addressed? Option A, only during the initial data ingestion phase. Option B, as a one-time check before model training begins. Option C, as a continuous process throughout the entire machine learning lifecycle, from ingestion to production monitor. Option D, exclusively after model deployment, focusing only on inference data. The correct answer is as a continuous process throughout the entire machine learning lifecycle, from ingestion to production monitoring. Here's the explanation. The overview and how it works sections repeatedly emphasize that data quality is not a one-time check, but a continuous process, starting from data ingestion through feature engineering, model training, and extending into ongoing model monitoring in production. The exam tips also state, remember that data quality is a continuous process in MLOps, not a one-time activity. It spans the entire ML lifecycle. Question 10. A data scientist observes that in a customer survey, respondents with higher income are less likely to disclose their actual income. What type of missingness does this scenario most likely represent? Option A, missing completely at random, MCAR. Option B, missing at random, MAR. Option C, missing not at random, MNAR. Option D, missing uniformly at random, MUAR. The correct answer is missing not at random, MNAR. Here's the explanation. MNAR occurs when the probability of data being missing depends on the value of the missing data itself. In this case, higher income, the missing value, directly influences the likelihood of it being missing, making it MNAR. Question 11. An MLOps team is deploying a model to production. During training, they used KNN imputation for a feature with missing values. What is a critical MLOps principle regarding missing data handling when this model moves to inference? Option A, the model should be retrained with a different imputation strategy for production data to optimize performance. Option B, missing values in production data should be handled by simply deleting rows, as imputation adds complexity. Option C, the exact same KNN imputation logic used during training must be consistently applied to production inference data. Option D, production data should always be imputed using mean imputation, regardless of the training strategy. The correct answer is the exact same KNN imputation logic used during training must be consistently applied to production inference data. Here's the explanation. A critical MLOps principle is consistency. The missing data handling strategy, e.g., KNN imputation, applied during training, must be consistently applied during validation and inference to prevent training serving skew and ensure reliable model performance in production. Question 12. In a production MLOps environment, an anomaly detection system continuously monitors incoming sensor data. The system detects a sudden increase in the percentage of missing values for a critical sensor. What does this situation primarily indicate, and what action might be triggered? Option A, it indicates a concept drift in the model, requiring immediate model retraining. Option B, It primarily indicates a data drift, potentially triggering an alert for investigation and pipeline adjustment. Option C. It means the model's accuracy has significantly improved, requiring no action. Option D. It suggests that the feature store needs to be updated with new feature definitions. The correct answer is, quote, it primarily indicates a data drift, potentially triggering an alert for investigation and pipeline adjustment. Here's the explanation. A sudden increase in missing values for a feature signifies a change in the input data distribution, which is a form of data drift. This should trigger an alert to the MLOps team to investigate the root cause, e.g., sensor malfunction, and potentially adjust the data pipeline or imputation strategy. Question 13. In the context of MLOps, what is a significant negative impact of duplicate data, particularly if present in both training and validation sets? Option A. It consistently improves model generalization capabilities. Option B. It leads to artificially inflated performance metrics, giving a false sense of model accuracy. Option C. It reduces computational resources required for model training and inference. Option D. It simplifies data versioning and management across the ML lifecycle. The correct answer is, quote, it leads to artificially inflated performance metrics, giving a false sense of model accuracy. Here's the explanation. The study material states that duplicate data in training and validation sets can lead to overfitting and artificially inflated performance metrics during evaluation, giving a false sense of model accuracy and generalization capability. Question 14. Which set of techniques is primarily used to identify near duplicates in MLOps as opposed to exact duplicates? Option A. MD5 hashing and SHA-256 hashing. Option B. Jacquard similarity, cosine similarity, and Levenshtein distance. Option C. Data profiling tools and cloud data quality services. Option D. Data versioning systems and monitoring alerts. The correct answer is Jacquard similarity, cosine similarity, and Levenshtein distance. Here's the explanation. The key features/components, section lists, hashing algorithms for exact duplicates, and similarity metrics like Jacquard, cosine, and Levenshtein for near duplicates. Question 15. In the process of handling near duplicates within an MLOps pipeline, what crucial step is performed before similarity calculations to minimize superficial differences? Option A. Applying cryptographic hashing algorithms. Option B. Immediately selecting a canonical record. Option C. Standardization and normalization of data fields. Option D. Deploying the model for inference. The correct answer is, quote, standardization and normalization of data fields. Question 16. What is the primary impact of outliers on machine learning models during the training phase? Option A. They always represent critical, actionable information that improves model accuracy. Option B. They can skew statistical measures, distort model parameters, and lead to biased or overly complex models that do not generalize well. Option C. They simplify the model's decision boundary, making it more robust to new data. Option D. They only affect model performance during the inference phase, not training. The correct answer is, they can skew statistical measures, distort model parameters, and lead to biased or overly complex models that do not generalize well. Here's the explanation. During the training phase, outliers can have a profound impact by skewing statistical measures, distorting model parameters, and leading to biased or overly complex models that do not generalize well to unseen data, resulting in reduced accuracy and poor predictive performance. Question 17. A data scientist is analyzing a feature that is not normally distributed and contains extreme values. Which outlier detection technique would be most appropriate to identify points falling significantly outside the typical range without assuming a normal distribution? Option A. Z-score method. Option B. Interquartile range (IQR) method. Option C. Grubbs test. Option D. Extreme studentized deviate (ESD). The correct answer is interquartile range (IQR) method. Here's the explanation. For non-normal distributions, the interquartile range (IQR) method is suitable, defining outliers as points falling below Q1 1.5 times IQR or above Q3 plus 1.5 times IQR. The Z-score method, Grubbs test, and ESD typically assume a normal or near-normal distribution. Question 18. In an MLOps context, why is continuous monitoring for outliers in production data crucial? Option A. Outliers in production data are always errors that indicate a faulty model. Option B. It ensures that all data points are removed before they can impact model performance. Option C. The emergence of frequent outliers can signal data drift, concept drift, or system issues, triggering alerts for intervention or retraining. Option D. It primarily serves to identify malicious activity, not data quality issues. The correct answer is the emergence of frequent outliers can signal data drift, concept drift, or system issues, triggering alerts for intervention or retraining. Here's the explanation. In an ML ops environment, continuous monitoring systems analyze incoming live data for new outliers. The emergence of frequent outliers in production data can signal data drift, concept drift, or system issues, triggering alerts for human intervention or automated model retraining, emphasizing its importance beyond just error detection. Question 19. What is a critical concern in MLOps that data transformation aims to prevent by ensuring consistency between the data seen during model training and the data seen during inference? Option A, model overfitting. Option B, data leakage. Option C, training serving skew. Option D, hyperparameter tuning inefficiency. The correct answer is training serving skew. Here's the explanation. The overview and how it works sections emphasize that consistency in applying transformations across training, validation, and inference stages is paramount for preventing training serving skew, where the data distribution seen by the model during training differs from that during inference, leading to degraded performance. Question 20. Which of the following techniques is typically used in data transformation to convert non-numerical categorical features into a numerical representation that machine learning models can process? Option A, standardization. Option B, min-max scaling. Option C, outlier detection. Option D, one-hot encoding. The correct answer is one-hot encoding. Here's the explanation. The key features/components, section lists, encoding categorical data, converting non-numerical categorical features into numerical representations that ML models can understand, such as one-hot encoding, label encoding, or target encoding. Question 21. In the context of data transformation, what is the significance of parameter learning during the training phase? Option A, it refers to the process of tuning model hyperparameters using the transformed data. Option B, it ensures that transformation parameters, e.g. mean for standardization, are derived exclusively from the training data to prevent data leakage. Option C, it involves learning the optimal sequence of transformation steps for a given dataset. Option D, it describes the process of automatically selecting the best feature engineering techniques. The correct answer is it ensures that transformation parameters, e.g. mean for standardization, are derived exclusively from the training data to prevent data leakage. Here's the explanation. The how it works section states, crucially, parameters for certain transformations, e.g. the mean and standard deviation for standardization, or the vocabulary for one-hot encoding, are learned only asterisk from the training data. This prevents data leakage from the validation or test sets. Question 22. What is the primary objective of implementing feature engineering pipelines in an MLOps environment? Option A, to manually manage feature creation for greater flexibility. Option B, to reduce the computational cost of model training by pre-calculating features. Option C, to ensure automated, reproducible, and consistent feature generation for both training and inference. Option D, to completely replace the need for human domain expertise in feature design. The correct answer is to ensure automated, reproducible, and consistent feature generation for both training and inference. Here's the explanation. The overview states that feature engineering pipelines automate the entire lifecycle of feature creation, ensuring consistency between features used during training and inference, which is critical for reproducibility and mitigating training serving skew. Question 23. How does a feature store primarily integrate with and benefit a feature engineering pipeline in an MLOps setup? Option A, the feature store replaces the need for any feature engineering transformations within the pipeline. Option B, the pipeline pushes its engineered features into the feature store, which then serves them consistently for training and inference. Option C, the feature store is only used for archiving old, unused feature definitions from the pipeline. Option D, the pipeline fetches raw data directly from the feature store for initial transformation. The correct answer is the pipeline pushes its engineered features into the feature store, which then serves them consistently for training and inference. Here's the explanation. Feature engineering pipelines generate the features, and then these features are stored in a feature store. The feature store then provides consistent access to these features for both model training and online inference, bridging the gap between feature generation and consumption. Question 24. Which critical problem do feature engineering pipelines primarily address by ensuring that the exact same feature logic is applied during both model training and real-time inference? Option A, model overfitting. Option B, data leakage. Option C, Training serving skew. Option D. Concept drift. The correct answer is training serving skew. Here's the explanation. The text explicitly states that feature engineering pipelines are crucial for ensuring consistency between the features used during model training and those used during real-time prediction, thereby mitigating the common and detrimental problem of training serving skew. Question 25. Which of the following is the asterisk primary times reason for implementing data versioning in an MLOps environment? Option A. To reduce the storage cost of large datasets. Option B. To enable real-time data streaming from model inference. Option C. To ensure reproducibility, auditability, and collaboration in ML projects. Option D. To automatically clean and pre-process raw data. The correct answer is to ensure reproducibility, auditability, and collaboration in ML projects. Here's the explanation. Data versioning is primarily implemented to ensure that ML experiments and models can be reproduced, changes can be audited, and teams can collaborate effectively by tracking dataset evolution. Question 26. A key feature of dedicated MLOps data versioning systems, distinguishing them from basic object storage versioning, e.g. S3 versioning, is their ability to, Option A, store full copies of every individual file when a change occurs. Option B, manage versions of individual objects without associated metadata. Option C, treat each version of a dataset as an immutable snapshot, often with metadata and delta storage. Option D, provide real-time access to the latest data for transactional systems. The correct answer is, quote, treat each version of a dataset as an immutable snapshot, often with metadata and delta storage. Here's the explanation. MLOps data versioning systems focus on managing logical times datasets as immutable snapshots, including associated metadata, schema, lineage, and often employing efficient delta storage or deduplication, which goes beyond simple object-level versioning. Question 27. When an MLOps data versioning system commits a new version of a dataset, how does it typically ensure data integrity and efficient storage without necessarily duplicating the entire dataset? Option A. It deletes the previous version and replaces it with the new one. Option B. It creates a full, independent copy of the entire dataset for each new version. Option C. It hashes individual files or data blocks and creates a manifest that points to these content address blocks, often leveraging delta storage. Option D. It stores only the changed rows in a relational database. The correct answer is, quote, it hashes individual files or data blocks and creates a manifest that points to these content address blocks, often leveraging delta storage. Here's the explanation. Data versioning systems use hashing to uniquely identify data content. They create a manifest, snapshot, that points to these content-addressed blocks and often employ delta storage to store only the differences between versions, ensuring efficiency and integrity. Question 28. An MLOps engineer needs to understand why a deployed model's performance recently degraded. They suspect an issue with the training data. Which MLOps practice would be most beneficial for tracing the origin and transformations of the data used to train that model? Option A, model versioning. Option B, data versioning. Option C, data lineage. Option D, A/B testing. The correct answer is data lineage. Here's the explanation. Data lineage provides the complete audit trail that tracks the origin, transformations, and movement of data through an entire machine learning pipeline. This makes it crucial for debugging model performance issues by identifying upstream data problems or changes. Question 29. Which component is central to capturing the detailed information about transformations, input/output datasets, and execution context at each step of an ML pipeline for data lineage purposes? Option A, a distributed file system for raw data storage. Option B, a dedicated metadata store or lineage service. Option C, a real-time stream processing engine. Option D, a simple train-test-split mechanism. The correct answer is a dedicated metadata store or lineage service. Here's the explanation. Data lineage is typically implemented by actively monitoring and capturing rich metadata, transformation logic, input/output schemas, execution details, at every stage of the pipeline. This metadata is then stored in a dedicated metadata store or lineage service for querying and visualization. Question 30. In a highly regulated industry like finance, an MLOps team needs to prove that sensitive customer data used for model training was properly anonymized and handled according to privacy policies. Which benefit of data lineage directly addresses this requirement? Option A, improved model accuracy through better feature engineering. Option B, reduced computational cost of model retraining. Option C, Enhanced model interpretability for business users. Option D. Support for regulatory compliance and auditing. The correct answer is support for regulatory compliance and auditing. Here's the explanation. Data lineage provides the necessary audit trail to demonstrate how data was handled, transformed, and used throughout the ML pipeline. This transparency is critical for satisfying regulatory compliance requirements, e.g., GDPR, HIPAA, and proving adherence to privacy and governance policies. Thanks for watching. Please subscribe to my channel